In this video, I will explain how to do linear programming in Microsoft Excel. And for this purpose, we'll be using this question. The question says, Racer Sport Products wants to determine the number of, there are two type of products they make, A and C, and this whole statement, a problem statement, has been formulated into this model. This is called as mathematical model, and which says that for football type A, the profit contribution is $5, and from C, profit contribution is $4, and this is subject to certain constraints. One of the constraints is cutting and dyeing, and it shows that the time it takes to make one A football is 12 minutes, and the time it takes to make C football is 6 minutes, and the total time is available 20,400 minutes, and everything must be produced in less than or equal to this number of minutes. Then the sewing department. In sewing department, football A takes 9 minutes, and football C, it takes 15 minutes, and that's the total time available. And similarly, in inspection and packaging, football A takes 6 departments, C also takes the same time, and the total time they have is 12,000. And this is non-negativity constraint, that's AC greater than 0, which means it is not possible to have these values as negative. They can be either 0 or greater than 0. Now when we will be doing all these things in Excel, we will make this type of table, and in that table I have already entered all the values. And in this table you can see this blue cells and then green cells. In green cells, I'll be entering formula. So this is profit contribution, and this is time that's taken. This is cutting and dyeing. This is sewing row, and the last one is, this one is inspection and packaging. So the first thing is objective function, and for this one what we do is that we will start with this one. I will enter all values, all formulas in green cells. So this one is equal to in this blue cells we want our values to appear, which mean the optimum number of football A and the number of football C that will maximize our profit, and our total profit will be equal to the number of A type football multiplied by profit that comes from A football plus the number of C football multiplied by profit from C football. That's our objective function, and of course nothing appears here because these cells are blank. Then in constraints, what we do is that we enter formula, and that formula is that 12 minutes multiplied by the number of A football, and let's convert into absolute value, plus 6 minutes in cutting and dyeing department multiplied by the number of C football, and also convert it into absolute value. And this is our this will give us the total number of minutes that will be used, and I can drag this one. Okay, so these are 4 formulas that need to be entered. The first formula is for this one objective function, and the other 3 for constraints. Before going to solver function, I would like to repeat these formulas one more time. The formula that we have entered over here, first of all, see that these blue cells, they are empty, and once we will run our program, the number of A football will appear here, and the number of C footballs will appear here, and our total profit will be equal to the number of football, A type football, multiplied by a profit from 1 plus the number of C type football multiplied by profit from 1 unit, and that will be our total profit. And this is the formula. And over here the time it will actually take, that's 12 minutes multiplied by the number of footballs, plus similarly 6 multiplied by the number of C-type football, and similarly the same thing is repeated in others. Now what we can do is that we can use a solver function, and in solver function we have this value, there's set objective function, that's d2, and our we want to maximize this, and we want to change variable cells, these one we want to change these blue cells, and these are constraints, and constraints which mean that d4 is less than e4, this is d4 is less than e4, d5 less than e5, d6 less than e5, d6 less than e6, and then make unconstrained variables non-negative and simplex L, and then I will click on solve, and once I will click on solve, these will be filled, these blue cells right now they are blank, they will be filled. This one, that's our total profit, it will also be filled, right now it's blank, and these cells they will also be filled. So let's see what happens. I click on solve, and it says that solver found a solution, and okay, and you see here that solver has automatically populated these cells, which means it says that if you want to maximize your profit with these constraints, you need to make 14 type of A football and 600 type C football, and when there will be 1400 football, 1400 multiplied by $5, so that will be something close to 7,000, and 7,000 plus 600 of type C football multiplied by a price of profit from 1 unit, that's 2400, so 7,000 plus 2400, that will be close to 9400, so that's the profit. And then next is this one, that it says that the time that it will take in cutting and dyeing department is 20,400, and the maximum time that's available is 20,400, which means that we are using our resources most efficiently, and there's no slack here. In the second one, the time that it will take is, this is the sewing constraint, and in the sewing constraint the time it will take is 21,600 minutes, and the time that's actually available is 25,200, which means we have some slack here. And the last one is 12,000, the time it will take to make these number of footballs, and the time that's available is also 12,000, so again it means we don't have slack here. The next thing what we can do is that we need to find slack, and slack for that what we can do is we can see this one, and that's the time that's available minus the time that it will actually take, and then we can drag it, and this is something that's a conditional formatting, and the idea of conditional formatting is that I can clear rules, and then from here we can see that highlight those cells where slack is something greater than 0. So any value that's greater than 0 will be highlighted. So you see that it says that this is in sewing department there is slack, in cutting and dyeing department there is no slack, in inspection and packaging there is no slack, but there is a significant amount of slack here, and it means that managers can channelize resources from sewing department to cutting and dyeing department or inspection and packaging if that's feasible for them.